All right, let's get started for today. So, what's good, everybody? Welcome back to Algebra-1 with Mr. Peters, another live stream. So, just remember that this video is a part 3 video. If you missed the first 2 videos, just remember it's down in our live streams. We're talking about Conquer Algebra 1, Ultimate Guide to Formula Skills and Terms. And then part 2 is Mastering Algebra 1, Advanced Techniques and Problem Solving Strategies. So in this last video, we're going to pick up where we left off with quadratic equations. And as a result, we're going to start off with the square root method. So when we're talking about the square root method, we're talking about quadratic equations, as I said, and it's going to look something like this. Ax squared plus c is equal to 0. And what we have to understand is that there's no bx term in this, all right? Now let's make sure that Facebook is with us real quick, family. 1 second. All right. And when we look at some of the examples that we have, this is how we're going to solve. So they'll give us an equation like this. And like I said, we'll notice that that bx term, or just a term with the single x, is not there. So we always want to isolate x squared. So after we subtract 7, we have x squared is equal to 81. And then we go into what we call the square root method. So the square root method is what we use basically to figure out what our x is. So we're going to get rid of the exponent by taking the square root, and we're going to do the same thing to the other side. So now these two cancel out, the exponent and radical. We have x is equal to positive or negative 9. Just remember that when we square a negative number, it turns positive. So problem number 2, they give us x squared minus 49 is equal to 0. Once we isolate that x squared, we're going to be at this step, right? Got it all absolutely by itself. Now we just need to figure out, Now we just need to get rid of the exponent. So we go back into that square root method. So now we get x is equal to plus or minus the square root of 49, and we know that's a perfect square, so it breaks down to plus or minus 7. So that's going to be our second example. Now, another way that you're going to see this problem is going to be like this in red. So they'll give us something where we have 2x squared minus 22 is equal to 28. So there's no difference here. Same exact thing. We want to get x squared by itself, so we add 22. Once we add 22, this is going to be 2x is equal to 50. X squared is not by itself. It's being multiplied by 2, so we divide to get it by itself. X squared is equal to 25. So now, variable, right, is isolated. We go back to the square root method. All right, this cancels out, turns just to x, and that is equal to plus or minus the square root of 25. And once we simplify one more step, we know x is equal to plus or minus 5. So this is what we're talking about when we talk about solving by the square root method. Now, before we go to the next topic, when we're talking about completing the square, just remember that when we're solving this topic, right, let's say we go back to this example. And where's my eraser? This is something that we just need to remember. This doesn't work if we're trying to take the square root of a negative number. So if I had something like this where it was plus 49 and then we isolated and we had this right here, just know that when we try to take the square root, this would be a no solution answer because we are not talking about complex numbers, right? So we can't take the square root of a negative number. And if you guys need more help with this, we just uploaded a video, how to master the square root method. So that would be very helpful to double down on this topic. But now we're going to go over to completing a square. And this is another topic that we use pretty often when we are working with quadratic equations. Okay, let's get this thing going. All right. So when we talk about completing a square, we have to understand what a perfect square trinomial is, and we have to understand how to create one. So when we have, let's start off with our problem. We have x squared plus 14x minus 51 is equal to 0. And they want us to solve by completing the square. So a perfect square trinomial is something like this, where we're basically multiplying the same binomials together. We FOIL it. And once we do, we'll get x squared plus 4x plus 4. And this is what a perfect square trinomial is, right? You multiply these two to get 4, you add them to get 4x. So this is essentially what we're trying to create. And when we're completing the square, not only are we creating a perfect square trinomial, but we also have to do this when its lead coefficient is 1. So now that we understand that basic, right? What we want to do in this problem is we're going to focus on A and B. So I'm going to move this over. So let's say we have x squared plus 14x, and then we add some c term, and that's equal to 51 plus the same c term. Oops. Because whatever we add here, we got to add it there. So how do we create the perfect square trinomial? We take that b term, divide it by 2, and then square it. So 14 divided by 2 is 7. 7 squared gives me 49. What I add here, I add there. So now I simplify this side first. And when we go back to this side, we're going to now break it back down to its perfect, basically to it's the binomial that gives us this answer. And remember, that's just b divided by 2. So when we take x plus 7 and we square this, it'll give us this trinomial. So now we've broken that down, and now we're completing the square. We go back into that square root method. So to get rid of the exponent, we take the square root, do the same thing on the other side. Those cancel out. We're left with x plus 7 is equal to plus or minus the square root of 100. Well, luckily for us, it's a perfect square. So x plus 7 is equal to plus or minus 10. We're going to bring 7 over on the other side. So now we have x is equal to negative 7 plus or minus 10. And this is just easy simplifying. Negative 7 minus 10, right? X is equal to negative 17. And then our second equation, we're going to do the opposite. So we're going to add negative 7 plus 10. And we get x is equal to positive 3. So when we're talking about completing the square, perfect example of how to do it with this. And we also have another recent video that came out, Dominate Completing the Square. So if you need more practice on this, you definitely will see this, use that video. All right, so that's just the basic completing the square. Now the next two problems that we're going to focus on is going to be completing the square. We're going to use that for a quadratic equation to switch it from standard form to vertex form. So let me just give you some more information what I need. So they give us this, right? X squared plus, is it 4x? Yep. Plus 4x plus 1. So this is the standard form of a quadratic equation, right? This takes this form. And what we want to get it to is this right here. This is that same equation for transformations when we're shifting parabolas or even absolute value graphs. So the way that we're going to do this, I'm going to show you two different ways. And like I said, we just uploaded a video on the same topic. So the way I showed in my previous video was this. So we're going to complete the square. So I'm going to section that off, right? So now I know y is equal to what? We're creating that perfect square trinomial. So x squared plus 4x plus 4. Half of 4 is 2. 2 squared is 4. Simple, right? So now, whatever we do on the inside of this, we're going to also do to the outside. And what I mean is, I'm talking about inverse operation. So you see how we added 4 here? On the outside, we're going to subtract 4. And like I said, the reason is to balance the equation. And hopefully by the end of this, you'll see what I mean. So we break this back down to its binomial, right? Y is equal to x. Oh yeah, that's right. Plus 2 squared. Then we combine this minus 3. Now it is in that vertex form. And if they asked us for the vertex, we know it's HK, which would be, the vertex would be negative 2, comma, negative 3. Now let me go back now and let me explain this step a little bit more. So let's say we didn't do it that way. Let's say we added on both sides of the equation. So we're at this step. Oops. Let's go back to the top. So let's say we put things on the other side. So I subtracted 1, right? So y minus 1 is equal to x squared plus 4x. Still going to complete the square, right? So y minus 1 is equal to what? X squared plus 4x plus 4. So let's say we just added plus 4 on this side too, right? Oops. Sorry, guys. So let's say we added plus 4 on that side. Now when we clean this up, right, meaning this side here, we break it back down to its binomial, we're going to have x plus 2 squared. Now over here, we balance the equation by adding it. Plus 4 and 1 is going to be y plus 3. Now we know we want to get y by itself to follow the equation, so we subtract 3. So when we get to the end, it's y is equal to x plus 2 squared minus 3. So when your teacher tells you to do it like this, that's just to save those steps from going from one side to the equation to the other. So by adding 4 here and then subtracting it on the outside, I basically took care of all these steps right here. All right, and now we're going to go into another example on this same problem. All right, so let's see what we got. All right, so let's go. All right, and just remember, guys, when I'm showing you this, do what works best for you. Okay, Pam, we could definitely get that down for you. Maybe not this video because we didn't plan for it, but we'll definitely get that out for you by the end of the week or early next week. So let's say we go back to this now, right? And I follow that same format. So what do I mean by following this format? So we're going to create that perfect square, right? Trinomial. Y is equal to x squared plus 8x. Let's see, half of 8 is 4, 4 squared is 16. So we add 16 here. Whatever we do the opposite on the outside of parentheses, so we're going to subtract 16. So now I break this back down. Y is equal to x plus 4 squared minus 21. All right, so we did it the shortcut way that Mr. Peters liked. Let's go back and do it where we were doing on both sides of the equation and see if we get the same thing. So from here, we added 5 on both sides, right? So y plus 5 is equal to x squared plus 8x. Now we create a perfect square trinomial, right? So y plus 5 is equal to x squared plus 8x. Half of 8 is 4, squared is 16. We add that here, we add that on the other side. So y plus 21 is equal to, and remember, we're going to break this back down to that binomial that we're going to square to get the answer. So x plus 4, I almost said 2, squared, right? And now at the end, when we subtract 21, we are going to get the same exact answer. And this is why I like to show it both ways, so that you pick and determine what you like better and what works best for you. All right, so we've done these 2 problems now. So we're done with completing the square. Like I said, we have recent videos that just came out about a day or 2 ago if you need more practice on this topic. So now we're going to go back over to rational expressions. All right. Yep. We're going to go over the rational expressions and just how to simplify them. So when we think about rational expressions, math family, just remember, right? We're basically talking about fractions with polynomials, or fractions that have a combination of variables, exponents, coefficients. So let's look at a few examples. That's number 1. All right, so just remember now, whole purpose of this whole complete review is so you guys can understand how all these topics are related and what to focus on if you're struggling with any one of these topics. So right here, right, we're talking about property of exponents, fractions. So let's say I just simplify my coefficients, right? If we divide by 12, we're gonna get 1 over 4, I believe. Let's double check the notes. Yeah, 1 over 4. Now we have properties of exponents, all right? We have x to the first power minus 3. We get x to the negative 2. No, we can't have that. So we gotta bring this down, right, to the denominator. So our final answer is 1 over 4 x to the positive 2 power, right? All right, perfect. So now we go over to problem number 2. Simplifying rational expressions again, right? Same topic. What we have up here is the difference of squares, right? So we know that middle term factored out. So this is x plus 8 times x minus 8 all over x plus 8. We know we could simplify fractions, right? Just cancel out, simplify. 1 is in the bottom. We don't need to put that. We just put x minus 8. So when we're talking about simplifying rational expressions, understand how factoring, properties of exponents, fractions are also involved. Now let's say, and let me see if I can get some more space. Yeah, let's get some more space so you guys can see this. So our last example before we switch topics, let's say we go over, oh, it's 2 of them, I'm sorry. All right, so here, same exact thing, math family. Can't do anything in the top, stays the same, but we have a trinomial we need to factor. So this is gonna be x plus 6 times x minus 4. Follows those trinomial rules, multiplies to give us negative 24, adds to give us positive 2. Cancel those 2 out. Even though there's nothing on top, we know there's a 1 over x minus 4. Oops. That's our final answer. I don't know why I circled that. Right? Now let's see, we go on to the next one. And in our next example, this is what they give us. We have 8x to the third plus 8x squared all over 10x squared plus 10x. So we should already know just from jump, we're probably going to use the greatest common factor. So I could pull out an 8 and at least x squared. So when I pull that out, right, 8x squared, I'm left with x plus 1. I'll go ahead and do the same thing. I could pull out at least a 10x. I'm left with x plus 1. Now, guess what? This cancels with this. We have 8 over 8x squared, 10x. Let's just say we divide 8 and 10 by 2. So now we have 4x squared over 5x. Perfect. Properties of exponents, 2 minus 1. So our final answer is 4x all over 5. And that is correct. So this is what I mean when I say, hey, understand where you lack at and touch back up on that area if you need help. Because there's a mixture of all these skills in one. All right, so we got through just simplifying the expressions. Now we're going to get over to multiplying and dividing rational expressions. And it's kind of all the same, honestly, guys. It really is. So I think I have about 2 examples on this. And I'm going to try to break it down the easiest for you. So number 1, we're actually not multiplying. We're just kind of factoring and simplifying fractions. So what does Peters mean? So this is what I mean. Difference of squares, right? X plus 2, x minus 2. We're good there. Bottom, GCF, right? We could take out 5. If we take out 5, we're left with what? X plus 2. Multiplied by x plus 2 over x minus 2. Now when we cancel, we could cancel from top to bottom or across. It's going to be the same answer at the end. Cancel those out. Cancel those out. Now I'm left with x plus 2 all over 5. So we don't actually multiply. If you want me to break it down into steps, we want to simplify by factoring, cancel like we did, and that's basically it, all right? So let's say we go to our second example. In the second example, we're going to do in red. So we have something different. Can y'all see this? Hopefully you guys can see this. All right. Matter of fact, let's just go back to black so we make sure it sticks out. X squared plus 9x plus 8. All right. Yeah, I'm gonna put this over here so we can see for sure. All right, so same exact thing, guys. Second example, we're gonna try to simplify. So I look at my top, that looks like we have x plus 2 times x plus 8. So this top now goes to x plus 2 times x plus 8. Same thing down here, GCF, but it's a different sign. So 5 by x minus 2. And we're going to multiply this by x minus 2 stays the same all over x plus 8 times x plus 1. So now that we have all those done, right, we simplify. The first step was just to simplify by factoring. Now we're going to cancel or simplify common terms, right? So we have x plus 8 with x plus 8, and then we have x minus 2 with x minus 2. So now when I simplify, I'm going to have x plus 2 on top over 5 times x plus 1. No, we do not need to multiply or distribute down there, okay? All right. So that's how to multiply basically rational expressions. Now we're going to go over into the dividing part. And the dividing part is basically the same exact thing. There's just one extra step. And I got you. Let's see what we got right now. All right, so math family, remember, this is a fraction. Anytime you divide fractions, keep, flip, change, right? So before we do anything, let's just do that. So this stays the same. Change this to multiplication, and then the second fraction gets flipped. So at this step, it turns right back into multiplying rational expressions. So let's say we've done the first part, we kept the first fraction, change it, all that. Now we need to simplify, right? And let's see, I'm gonna speed this up by looking at my iPad. All right, so right here, x minus 5 times x plus 3 all over x minus 2. Let's double check, that's correct. Times x minus 2 all over, and I wanna say this is x minus 5 squared, right? Yep, it is. X minus 5 times x minus 5. So it's the same exact thing. We just have to do that first step of creating an actual multiplication problem. Cancels out with x minus 5. X minus 2 cancels out with x minus 2. This is what we're left with. So my final answer is x plus 3 all over x minus 5. Double check the notes. Yep, we're good. So when we talk about multiplying or dividing rational expressions, remember that that topic is basically the same exact thing, okay? And I got one more example before we go over to what I believe is rational equations. Oh no, not yet, okay. All right, so let's say we had this instead now. So they gave us this. All right, so math family, they like to do this to kind of confuse us. But if you just turn this into a fraction from the beginning, then you'll be good. All right, so first fraction stays the same, right? Change this into multiplication. Even though this was a whole number, we change it into a fraction. Now we flip it, take the reciprocal. Now we're back to multiplying. So the biggest thing when you do is just break this difference of squares down as x plus 9 times x minus 9. And when we look at this, x plus 9 cancels out with x plus 9. And we're left with x minus 9 over x. No, we can't simplify this any further, okay? So this would be our answer. All right, so now we're done with that part. We did simplifying, we did division it and multiplication of rational expressions. Now we're gonna do adding and subtracting. All right. Okay. All right, math family. So when we're doing this, right, we should obviously starting off with rational expressions with the same base. So when we're adding fraction with the same base, the bottom, we don't do anything to it. We focus on the top. So 8 over 4x, remember, rational expression, we always try to see if we could do what? Simplify. So now we simplify, and we're going to get 2x basically. Yep, 2x. Now go over here, same exact thing. So all I'm going to do is focus on the top, right? Because the bottom stays the same. So what am I going to have? Yeah, that's right. All right. We're going to have 2x plus 2, right? After we combine -4, +6. Now I get here, I do my GCF factoring. So I have 2 times x plus 1 all over x plus 1. Cancel x plus 1 with x plus 1. Final answer is 2. So just a quick introduction. Now we're going to focus on when we have different bases. And when we have different bases, what we're going to have to really do a lot of the times is just multiply. So this is what I mean. So let's say we have 6x over x squared minus 9. And we're going to add x over x plus 3. So the first thing we always want to do when we're adding rational expressions with different bases is find a common base, which would be x plus 3 times x minus 3, right? So when I break this down here, oops. What I'm going to do is I'm always going to multiply the numerator with whatever I added. So this fraction was missing x minus 3. So what I'm going to do is take the numerator and multiply it by x minus 3. So we turn this all into one fraction because there's a common denominator. We have 6x plus x squared minus 3x all over x plus 3 times x minus 3. Now let's just double check, make sure we're on the right path. Yep, we are. So now we're focusing on our like terms. So we have x squared plus 3x all over x plus 3 times x minus 3. I'm going to switch back to black. This is a little too dark. All right. Greatest common factor, we take out x. We're left with x plus 3 all over x plus 3 by x minus 3. And now you guys know we're going to cancel. All we're left with is x all over x minus 3. So when we're talking about adding, biggest thing is finding that common denominator and making sure that wherever you have to add that factor in, you also do it in the numerator so that we have a common denominator, okay? And let's see. Yep, that's right. Okay, so let's do one more example on this. Okay, so let's say in our second example on the same topic, they give us a different problem. 8x minus 26 all over x squared minus 4x minus 21. And we're going to subtract 3 over x minus 7. Now, family, just remember that 9 times out of 10, they gave us one of the factors. So when we go back here, right, we have 8x minus 26 times x minus 7 times x plus 3. So we know the common denominator is x minus 7 times x plus 3. So when we go over to the second fraction, hold on, let's just write this in. We're going to be multiplying top and bottom by x plus 3. Write it in red so you all can see the what we're adding in. So at this step now, all right, I'm not going to worry about the denominator. Let's just focus on the top. So we have 8x minus 26 minus 3x minus 9. Let's make sure. Yep. Just remember this negative makes 3 negative. So that's why we have negative 3x, negative 9. So now we combine these, right? 5x minus 35, is it? Yep. Now I add back the denominator in. All right, so at this step, we're not done. GCF factoring. I pull out 5, right? So I'm left with x. Oops, sorry, too fast. I pull out 5, I'm left with x minus 7. Then the denominator is still the same, x minus 7 times x plus 3. Math family, y'all know what's going on. We're going to cancel out. And you're absolutely right. X minus 7 with x minus 7. Final answer is 5 over x plus 3. All right? So we wrap that up now. We've done dividing, simplifying, adding, and subtracting rational expressions. Now we're going to get over to the rational equations. And then we're on the final topic of radical equations. All right. And we really hope that this video is helpful for you all, man. I really do. And thank you all for joining our live streams. All right. So with this problem, we could solve it similar to the last part of this video where we're talking about adding and subtracting rational expressions. So in this part, I'm not going to find the common denominator. I'm going to show you I'm going to show you a trick, basically, a shortcut, which is we use the properties of proportions to create equations. So we have 5 times x minus 2 is equal to 2 times x minus 8. Just make sure you distribute, okay? So when we simplify further, 5x minus 10 is equal to 2x minus 16. And now this just turns into a regular equation with variables on both sides, or even multi-step equations. So I subtract 2x. We have 3x minus 10 is equal to negative 16. Let's add 10 on both sides. I have 3x is equal to 26. And when I divide by 3, let's make sure I'm on the right page. Whoa, hold on. I think I did something wrong. X minus 10, 2x minus 16, that's 3x. When we add, here we go. I knew I did something wrong. All right, so I'm sorry. This is 3x is equal to negative 6. This is where I made my error. So we caught ourselves. Hey, math family, if y'all ever see errors on my videos, please call me out. I do make mistakes from time to time. All right, so now we divide. X is equal to negative 2. Okay, so we're good. This is when we're dealing with linear equations. So there's two situations when we use this type of method. We use the proportions to create a linear equation, or we use the proportions to create a quadratic equation. So let me show you an example of that. So let's say we had this rational expression, right? Or equation, I should say. I'm sorry. All right, so we're gonna start off with the same process. Cross multiply. Negative 7 times x, draw a little barrier, is equal to what? X plus 1 times x minus 12. So we know we're gonna distribute. So negative 7x is equal to x squared minus 12 x plus x minus 12. So we simplify one step further. All right, that's what we should have. Now I'm going to add 7x x squared is, is it minus 4? Yeah, minus 4x minus 12 is equal to 0, right? So we created our quadratic equation. We've combined our like terms, and now all we need to do is just factor and set our factors equal to 0. So we're gonna have, let's see, all right, yep, x minus 6 is equal to 0, so we know x is equal to positive 6, and x plus 2 is equal to 0, so we know x is equal to negative 2. So when we're talking about solving rational equations, we could always find a common denominator, right? Or we could also use properties of our proportions and cross multiply to create a linear equation or quadratic equation. And just remember, if you create a quadratic equation, you have to factor, and it may not always be a simple factor like this. All right, so now we're getting on to the very last chapter of this live stream. And like I said, thank you guys so much for joining us. Smash the like button if this was helpful for you. If you're someone like Pam who wants to request a video topic, please comment down below too. We'll try to get that in the next few days. All right, so now we're talking about radical expressions and equations. So we're going to talk about simplifying radicals a little bit. All right, so just remember when we're working with radicals, guys, we're trying to basically divide with the largest perfect square. So when we look at 54, the best thing we could do is 9 times 6. Always want to use the largest perfect square. And anytime we have a perfect square, we're going to take its square root out from under the radical. And if there's a number outside, we're going to multiply it. So this will be 2 times 3 times radical 6. Final answer is 6 radical 6. Right? If we have a perfect square like this, simple answer. Just turns into its square root. And if they give us variables, it's the same exact thing. This is basically saying the square root of 7 squared. 7 squared is 49, so it would just be what? 7. So if we look at this, the square root of x squared is just x. So those are like conceptual questions to make sure you understand, right? Because this is the same thing. This is saying x squared. If it was 7 squared, it would be 49. If it was 49, square root of 7, okay? Which is basically just itself, its square root. All right, so those are just the basics. Now let's say if we had different examples now, right? And remember, when we're taking the square root, we're looking for pairs. So let's say if we had x to the third, right? We would break this down as x squared times x. Because every square is how we take the square root. So if we looked at this comes out as x. Because we only have 1 and not a pair, this stays under the radical. So x to the third simplifies to x radical x. Now let's say if I did the same exact problem with a larger radical, or exponent I should say, x to the fifth, right? We're going to do this as x to the fourth times x. And another secret, the way I teach in some of my other videos, if we're talking about square roots, meaning that the index, the root is 2, just split it with your largest even square, right? Look, even square, we take it out, it's just x. Now we have our even square. When we take this out, it's just x squared, radical x. You typically divide your exponent by the root. 2 divided by 2 is just 1. 4 divided by 2 is 2. We're able to pull out 2 pairs of x squared. That's all it is, okay? So let's say now we're going to bring this back and we're going to do like a mixed review. We have variables and coefficients, I should say. Appreciate you guys, man. I love you, math family. All right, so let's do these 3 problems. So we have 125, x to the 6, y to the 5th. And we're gonna write all these. Oh yeah, there's only 2 though, okay. All right, perfect. All right, so let's do it like this. And like I said, family, it's whatever works for you. So when I draw this down, I like to keep the perfect square and the non-perfect square. So what do I mean? The perfect square that goes in this is 25, right? What do we multiply 25 by? I believe it's 6, right? Is it 6? Hold on, let me double check. I think I'm tripping right now. Okay, 5. I'm sorry. I don't know why I had to bring 5. So we have 25 times 5, right? This exponent is even, so we're just gonna keep it over here. Highest even exponent, y to the 4th. That extra 5th one goes with the non-perfect square. Remember, these are perfect squares, so 25 comes out as 5. X to the 6, right? How many pairs of 2 do we have? 3. X to the 3rd. How many pairs of 2 do we have? Y squared. This stays under the radical. Double check the notes. That's absolutely correct. Yep, it should be, because, yeah, that's correct. All right. Now we go on to the next example, right? 27. So the largest perfect square that goes into 27, we know is 9. So we have 9 times what? 3. Odd exponent, I'm gonna keep the even with my perfect square. So that's x squared, other x is here. 9 turns into 3. X squared comes out, turns into x. Because we can't take the square root of 3x, it stays under the radical. Yep, so 3x times radical 3x. So when we're talking about radicals and how to simplify with just variables, right, and exponents, or just a number or a combination, this is how you would do it, okay? And with that, all right, we're on good time. Okay, good, all right. I'm doing good. So mathematically math, I see your comment, but I didn't understand it 100%. All right. Well, hopefully you retype it in and I can understand, but we got 3 last topic, guys. We're gonna talk about distributing with radicals and rationalizing the denominator, and we're also just gonna touch on solving equations with radicals. So about 3 to 5 more problems, and I'm gonna let y'all enjoy y'all Wednesday night, okay? And like I said, thank you guys for watching. All right, so we have 5 radical 7, and we're going to add this with 3 radical 63. Now, family, to add radicals, right, we have to have the same exact radical, meaning the number under it has to be the exact same. So right now we can't add. However, we can simplify. So this stays the same because we can't break it down. No perfect square goes into 7. But a perfect square that goes into 63 is 9. All right, so 9 multiplied by 7 will give us that radical. So this comes out and it's going to turn into 3 times the square root of 9, which is 3. Radical still stays under. I'm going to bring this down. So now we just multiply. So we have 5 radical 7 plus 9 radical 7. When we simplify, all we do is add the numbers in front. 9 plus 5 gives me 14. Radical 7 is just like a variable. It's just going to stay the same. So final answer, 14 radical 7. Oh, I'm sorry, man. I didn't see the algebra 2. Oh, I got some topics of algebra 2. Y'all know me, man. I love this math, man. I'm sorry. All right, but I got y'all, man. Thank you for the comment. And thank you for clarifying. All right. So next thing they like us to do as well, right, is let's say we have this problem here. And the reason I want to do this problem is just to let you guys know that you're not crazy if you can't combine all the radicals, right? So they gave us radical 12 plus 75 minus radical 3. We break 12 down as 4 times 3 simplified to 2 radical 3, right? And then when we go to 75, we have 25 multiplied by 3. Perfect square is 25. It comes out as 5 radical 3. And then this last one is just radical 3. So sometimes they may give us a problem where only 2 radicals can be combined and the third one is different. And sometimes all of them could be combined. So when we look here, 2 plus 5 is 7. There's no number in front here, but we know it's an understood 1. So 7 minus 1 is 6. And our final answer is 6 radical 3. Okay? I like that. I'm glad the reviews are helpful. All right. So boom, right? So we're done right here now with just adding. We're going to go into multiplying, and we're going to do one, hopefully, distributive property if I wrote that down. All right, so when we go back now, guys, just remember, when we multiply, it's kind of ghetto, all right? And this is what I mean by it's kind of ghetto. The whole rule switch up is much different. So what we're going to do now is we're going to multiply numbers with numbers, radicals with radicals, and then we're going to double check the radical to see if we could break it down. So I only have one example on this, I believe. So what do I mean? 4 times 2 gives me 8. 6 times 3, or radical 6 times radical 3 gives me radical 18. So we multiplied it, right? However, we could break this radical down. So we have 8, and then radical 18 to be 9 times 2. We know this is the perfect square. So now we have 8 times 3 times radical 2. This gives us 24. Radical 2, let me double check. All right, I think I'm good, right? Yeah, I'm good. Okay, now next topic. Let's say they give us something like this. 2 over radical 7. They tell us to simplify. So family, you guys know we cannot have an irrational number, aka a radical, in the bottom of the fraction. All right? And man, I appreciate you guys for the comments, man, because it helps me too. Y'all, as I'm helping y'all, y'all help me too, so thank you. So what we want to do is rationalize the denominator. All that is a fancy word for saying, hey, we're going to get rid of the square root. And typically, we do that by multiplying by the same exact radical, right? And what we do in the bottom, we do to the top. So remember, this just stays as 2 radical 7. You don't actually multiply those. Then when we multiply radicals, remember, we actually multiply the number under there. So this is radical 49, which is a perfect square, which simplifies, right? Top stays the same. Bottom changes to the square root of 49, which is 7. So anytime you see a problem like this, you're going to multiply by the same exact number under the radical, all right? The same radical. Now, I know what y'all thinking, but Peters, it's never like that. You're right. I got you with another one. This is what they're really gonna give you. That's the baby stuff. This is what they're really gonna give you, okay? Okay. No, I don't like that marker. Toss it on the floor. Alright, so for you guys, I promise you these are my last 2 problems. Alright, and then we're done for today's live stream. I got y'all. 1 hour is enough. All right. All right. So now, when we talk about rationalizing the denominator when we have a binomial, meaning 2 terms, this is when you hear the word the conjugate. And the conjugate is the same exact binomial with the opposite sign. So you see how this is radical 5 plus radical 3? Now we're going to have radical 5 minus radical 3. And what we do in the bottom, we do to the top. Okay? I don't like when I do small mistakes like that. All right, boom. So why does that matter? Remember, this is the difference of squares, right? So let's just use the box method because I need y'all to really understand this because it's just something that you're gonna see so much, and the more you understand it, the easier it is. All right, radical 5 times radical 5 is radical 25. This is just 5. It's just the same number under the radical. Right here, this is radical 15. This is negative radical 15. Guess what? They cancel because it follows the difference of squares, right? Minus radical 9, which is just 3. right? Because the difference of squares, right? X plus 4 times x minus 4. We just multiply the first two to get x squared and the last two to get negative 16. This is the same exact concept. So what does that mean? We're going to skip some steps to make it easy. All right, so hopefully you guys are with me on that. So now when we go back to this, all right, we distribute. So we have 4 radical 5 minus 4 radical 3. I think that's pretty self-explanatory. Now we go on the bottom, right? We're going to get radical 25 minus radical 9. Now we simplify it, right? Because we know the middle terms are going to cancel out. I ain't even going to worry about it. I'm not. So top stays the same. 4 radical 5 minus 4 radical 3 all over 5 minus 3. So now I go one step further. We're going to subtract in the denominator. And yes, y'all boys and girls, y'all got it right. Yes, we can. Yes, we can. We're going to divide by 2. So the radicals are not affected, but this is going to turn from a fraction to a whole number. So now we have 2 radical 5 minus 2 radical 3. So when we have a fraction with radicals and it's in the binomial, right? So binomial with radicals, we're going to rationalize it with the conjugate, which is the same exact expression, but the sign is opposite, following difference of squares, okay? So hopefully that was helpful for you guys. All right, and now we're gonna go over to the last video of this day. And like I said, man, guys, thank you so much for joining our live stream. Make sure you comment down below on our lives and our regular videos for topics you'd like to see. And starting May, we're gonna come out with videos on Sunday, 1 question videos for that test prep Sundays. Check the community tab if you want to hear a little bit more about it. I posted a question in there. All right, so now we go over the radical equations. Let's say they gave us, there's 2 problems. All right, I'm gonna do this real quick, man. I'm sorry, man. I'll be lying to y'all, man. I'm sorry, man. All right, 6x minus 2x. All right, very similar to the square root method, but it's kind of the opposite. So if we're solving radical equations, the first thing we want to do is isolate the radical itself. So we're going to subtract 5. So we have radical 6x minus 2 is equal to 10. So remember, the square root method and this are kind of the opposite. So remember, we would have a square root, and to get rid of it, my bad, I'm trying to rush to keep y'all on so y'all don't leave too soon, my bad. Radical equations and the square root method are kind of the opposite. Why? Because when we had the square root method, to get rid of the exponent, we take its square root. Now when we're working with this, it's the opposite. To get rid of the radical, we're going to use our exponents and take it to the second power to get rid of that radical. Same thing on the other side. So the square root cancels out with the radical. We're left with 6x minus 2 is equal to 100. Okay? And now with this step, it's just a regular equation. Add 2, 6x is equal to 102. I divide by 6. X is equal to, let's grab the calculator. Ooh, damn. Damn, the real dean, damn, 50 out of 58, okay, dang, man. I gotta shout you out, that's what I'm talking about. That's what I'm talking about, it feels good, doesn't it? Wow, that's amazing. Hey, man, y'all make sure y'all show some love to the real Dino in our comment section, man. That's what we're talking about, guys. We're here to help. All right, so x is equal to 17, okay? And now this is the final problem of the day, guys. I'm sorry. This is when we have more than one radical. This is a basic problem, all right? So let's say we have p minus 3 squared. No, I'm sorry, no. P minus 3 is equal to radical 5p minus 15. All right, so this is our last problem. And like I said, when we look here, right, we're going to do the same exact thing. To get rid of the radical, we square it. Same thing on the other side. So now this is just 5p minus 15. Family, please try not to make this mistake by moving too fast. We're not just squaring p and 3. We're going to take p minus 3 and multiply it by itself. So just please understand that, because this is where students make a mistake. So when we FOIL, we'll have p squared minus 6p plus 9. Perfect. Now we're going to combine. It's going to be a quadratic equation in which we factor. So we subtract 5p, right? P squared minus 11p plus 9 is equal to 5, negative 15, I'm sorry. And then, hold on 1 second. Okay, that's right. We add 15. Now we have p squared minus 11p plus 24 is equal to 0. Yeah, that looks right. That looks right, okay. Now we factor. I'm gonna get our two parentheses. Let's see, what do we have? So signs have to be the same and it's negative. So let's try this. 8p, 11p, 24. All right, so I think that's correct. So now we have p minus 8 is equal to 0. We get p is equal to positive 8. And then in our second one, p minus 3 is equal to 0. So p is equal to 3. So that is it on our live stream today, guys. This is the third video of the complete algebra series. Like I said, comment down below for those algebra 2 topics or other topics you guys would like to see on my channel. And thank you guys for being the best math family on YouTube. Appreciate you guys, and we'll see you on the next live stream. Check the community tab for those dates.